This video is about dependent sources. Independent sources provide a specified voltage or a current to a circuit regardless of the circuit itself. Dependent sources adjust the voltage or current they provide based on a voltage or current somewhere else in the circuit. As with independent sources, dependent sources provide power to a circuit. However, unlike independent sources, dependent sources adjust the power they provide based on conditions in the circuit itself. Since dependent sources provide power from a source external to the circuit, they are active circuit elements. But the voltage or current they provide is controlled by a voltage or a current within the circuit. Symbols representing dependent sources are shown here. The dependent source is indicated by this diamond-shaped symbol rather than the circle we used for independent sources. An arrow inside the diamond indicates a dependent current source, while the plus and minus signs indicate a dependent voltage source. As with independent sources, the arrow indicates positive current direction, and the positive and negative signs indicate the voltage polarity sign convention. Since the source can provide either a voltage or a current, and the source can be controlled by either a voltage or a current, there are four possible types of dependent sources. A voltage source that's controlled by a voltage elsewhere in the circuit is a voltage-controlled voltage source. A voltage source controlled by a current is a current-controlled voltage source, usually abbreviated as CCVS. A current source that's controlled by a voltage is a voltage-controlled current source. And finally, a current source that's controlled by a current somewhere else is a current-controlled current source, or CCCS. Here are a couple of examples of dependent sources. This one is a voltage-controlled voltage source. The circuit symbol indicates a voltage source, and the voltage it applies is some number, K, times a voltage elsewhere in the circuit. So it's a voltage source that's controlled by a voltage. This is a voltage-controlled current source. The current that the source puts out is based on a voltage somewhere else in the circuit. There are a variety of common circuit components that behave like dependent sources. Transistors, for example, appear nearly everywhere. One category of transistors is metal oxide semiconductor field effect transistors, or MOSFETs for short. A common use for MOSFETs is to implement the switching operations that make computers work. Fundamentally, they tend to behave like voltage-controlled current sources, though they can be made to behave like other types of dependent sources with external circuitry. Another type of transistor is the bipolar junction transistor, or BJTs. These are often used in amplifier construction. Operational amplifiers are super useful devices, as we'll see later in this course. They're constructed using MOSFETs and BJTs. One really neat thing about operational amplifiers is that they can be used to build circuits that perform mathematical operations, which is the source of their name. So you can easily implement operations such as addition, subtraction, multiplication, integration, and differentiation with operational amplifier-based circuits. Finally, let's take a look at a circuit that uses a MOSFET to implement a dependent source. This is the circuit symbol for a MOSFET. It has three terminals: a gate, a drain, and a source. When the gate voltage, VG, is low, the MOSFET does not allow current to flow from the drain to the source. If VG is high, the MOSFET does allow current to flow from the drain to the source. Current through the MOSFET is being controlled by a voltage, so this is a voltage-controlled current source. Since the circuit's an active component, it provides power from an external source. I'm using a 9-volt battery to provide power. This dependent power supply requires an independent power supply to function, which in this case is the 9-volt battery. The circuit's controlling the current leaving the battery based on a voltage applied to the MOSFET. Now let's implement this circuit and see how it works. I want to use my analog discovery to turn this motor on and off. Unfortunately, the analog discovery itself doesn't put out enough power to turn this motor. So I've created a dependent source that's controlled by the analog discovery. This 9-volt battery provides power to the drain of the MOSFET. The source of the MOSFET is connected to the motor, which is connected to ground, and channel 1 of the analog discovery is applied at the gate to turn the MOSFET on and off. So when this voltage is low, no current flows to the motor. When this voltage is high, I get to flow current from the battery to the motor, and it turns the motor on. So right now, the voltage is 0 and the motor's off. Let's change that voltage to a high voltage, 5 volts. That turns the motor on. Going back to a low voltage, turns the motor off again. That's all I want to say about dependent sources for now. I'll talk about dependent sources again later when we do amplification. Also, if you take a later class in electronics, you'll model transistors as dependent sources. The next video is about resistors. Resistors, unlike sources, have a functional relationship between voltage and current at their terminals. That relationship depends upon the passive sign convention. If you're unsure about the passive sign convention, it'd be a good idea to go back and review that before you go on to resistors.